All right, welcome everybody. This is a yet another Trino meetup that we are so graciously hosting, and really excited to showcase some of the interesting things that are going on in the Trino community. And today we are joined by Barak Emre. Welcome, Barak.
Hey Brian, thanks for having me.
And also our typical, typical, what is it? The phrase that I'm looking for is a partner in crime. Neetu Agashwami. Welcome, Neetu, again.
Hi, everyone. Glad to be here.
And we're going to be talking today about addressing query aggregation performance between analytics tools and Trino. And so it's a bit of a mouthful, but I'm really excited about this one. It takes some of the themes that we've talked about in previous meetups and Trino community broadcasts, particularly around DBT, and basically combining DBT to enable a lot of extra activity. This also looks at looking at these aggregation queries that happen and trying to essentially optimize those wherever possible by applying a lot of these techniques where we're essentially trying to specifically focus in on aggregates and cache them, and Barak will be talking a lot about how this works and how it pairs really well with DBT. And so really excited about this, but I'm not here to talk to you about that. I'm just here to talk about the community stuff and the free shirts. So without further ado, start out with the community stuff. As I said, agenda is going to be Trino and Starburst overview by Neetu. And then the main meaty topic will be covered then by Barak. Wanted to give a quick shout out to some of the folks that are saying where they're joining from. So welcome, Chris from Austin. And really excited to have you here. Let me know if anybody else wants to holler out where they're tuning in from. Then let's do a quick little overview on some community links that I like to make aware for people that maybe this is the first time joining. So we have a couple of resources out there. If you are new to the community, you are using Trino, or you are administering Trino and you're a data engineer, or you just needed help getting the SQL query to run a little bit faster, we have a lot of resources out there for you. So first off, this Trino Slack, that is, I would say, the kind of quintessential resource. And that is where a lot of the creators, the contributors, maintainers all hang out, as well as a vast majority of the community in Trino land. They all are they're kind of on and off, but if one of those like primary contributors are not there to help you at that time, we have 5,400 people that have currently joined the Slack channel, and an average of about 550 active on the Slack channel at any given time. So that just goes to show you'll have quite a huge amount of resources of people to lean on and answer your questions. And we're trying to do even a better job of making sure that we get to all the questions that come through. Obviously, as we have 5,000 people, there are some questions that maybe sometimes come in, but we're getting better at it. And so all you need to do is go to trino.io/Slack. And that will basically take you to a webpage that has a link. You click that link, and that is automatically the invite. There's no special invite that you're going to need there. We also do, I was about to say bi-weekly Trino community broadcasts. We've actually scaled that back to monthly Trino community broadcasts. And that is actually for the intent that we will be focusing a lot more on enablement content, trying to basically make documents come to life through videos. So more to come on that in the upcoming meetups. Obviously, Trino virtual meetups, that is another great resource, and you're here. We have one for various segments of the globe. We have the Americas, which is the one that you're in now. We have EMEA, and we have APAC. So if you are, traveling over, or you're originally from EMEA area and that's where you're heading back to, also recommend that you join that group. There's going to be a lot coming up there, and really excited to showcase that. If you don't have or if you want to basically not want to have to write all this stuff down, by the way, check out the link that was just sent into the chat, and we'll be having all of these links plus more at that webpage there. Finally, if you want to contribute to the project, if you're a developer and you thought, hey, Trino sounds really cool, I want to be a part of that, you can go to Trino.io /development. That's going to basically give you a lot of the, bring you into the world of like, you need to first sign your CLA, which is a license agreement, which, just agreeing to the Apache 2.0 license. And then basically, once you get that accepted, you make a fork of Trino, and then we'll start. We'll walk you through the process, and again, join Slack to help you through that process of deploying to and becoming part of the contributor list. Then also, another incredibly helpful way that you can join the community outside of just writing code is writing blogs or documents. Documentation is a huge part of any, basically of any project that is going to be trying to take off. You really need help for newer folks that are learning about the system to have accurate and very well describing documentation. So that is a huge way to help. And if you're still just trying to dig in and understand Trino, that's also a very nice way to get started as well. And same thing with the blog. So for the blog, we have a link to these blogs. If you want to write a blog, you reach out to me on Slack or reach out to really anybody on Slack, and we will come find you and work on getting anything that you want to say about the Trino community out there. Real quick, wanted to give a quick shout out, Eric, long and faithful fan, and really excited, always coming from New York. And thanks for joining us today as you've joined us in other sessions. Hopefully we'll be having him on, I think in, I would say it was March timeframe. So we'll be seeing Eric actually doing one of these meetups himself. Don't hold me to totally accountable on that date. I can't remember exactly if we did say March or not. So one of the big announcements I wanted to bring up was this Trino forum we have is a site that my team, and my team being just me for right now, hashtag if you want to get into the developer land and do developer advocacy, come talk to me. I need I have a head count open for developer advocate. But my team is in charge of running this Trino forum. It is a Trino forum that is hosted by Starburst. That is also on the community that community resource list. Please sign up for it. It's a really good resource. We are going to be curating a lot of the information that comes in around Trino for specifically the Stack Overflow, Slack channel, anything that is kind of in all these disparate areas. We're kind of centralizing the knowledge and trying to make this kind of really solid knowledge repository that we go through and check the answers. We make sure that the answers are accurate and correct. A lot of the issues that we see sometimes in Slack is that people are very nice and trying to answer and help others, and sometimes they give the wrong answer. So we try to do our best to kind of like help those people that are still learning about, Trino, that are trying to help other people. We just try to do a little bit of a secondary fact check, and we do that a lot more on Trino Forum. And it's also nice because it gets indexed by Google and then is searchable to other people. So really excited about Trino Forum. If you are also joining the Slack channel, this is yet another good resource that condenses a lot of the information that you'll find there. Finally, let's get to the part that everybody gets really excited about. And bye. We went back away from it. No. So we have Trino shirts that we give out at these. If you have not gotten a Trino shirt yet, please go to this link. It is also included in the link that was shared in the chat just before. And actually it's just shared just now. Thank you very much. Basically this is going to have a cool little Commander bun sitting in the front there. You just go there, sign up with your information, your shirt size, and all the details of where we're going to send the shirt to. And we will send it to you. Thanks for attending this meetup. And yeah, definitely let us know. And going by the honor system here, if you've gotten a shirt before, if you sign up for twice, we will graciously give you another one. But honor system, please reserve it to one so that we can get it for multiple people in the community first. All right, So any questions that you have, ask on YouTube chat as we go throughout the talk today. Again, join Trino Slack, follow us on Twitter. We'll have a couple little calls throughout the show today. And without further ado, Neetu, could you tell us a little bit about this amazing query engine we have called Trino, and what is this company that I work for called Starburst?
Thank you so much, Brian. Everyone, welcome. I know it's pretty late, but I'm excited to be, with this community and dedicated to, just expand this community. So if you know of anyone that is in the big data world and is looking to just explore new technologies, definitely bring them on. Just quick introduction. My name is Neetu Goswami. I cover Eastern Canada at Starburst. And for those of you who are joining us for the first time, I'm just going to be spending a couple minutes first introducing Trino and then what is Starburst. Okay. If you have any questions, definitely feel free to put that in the chat and someone will get to that. Okay. So very quickly, I want to just start with what is Trino, right? You can see Martin, Dane, David, their pictures are here. So first off, Trino is, formerly known as Presto SQL. It's an open source distributed SQL query engine. Essentially MPP, query engine. So distributed query engine, which is essentially with ANSI SQL, the most standard format of SQL. And it's created by Martin, Dane, and David. In 2012, when Dane, David, and Martin joined the Facebook data infrastructure team, together with Eric Huang, they created Presto to address the problems of low latency interactive analytics over Facebook's massive Hadoop data warehouse. So, with the army of data scientists that they had, they could not really scale their queries. And low latency was one of the requirements. And, getting any queries into the Hadoop data warehouse was, very, very slow. So just to address those problems, Dane, David, and Martin actually created Presto. And so what is Trino then, right? Like, what exactly is it? Like, sometimes when I get into conversations, it's very easy for us to kind of break it down, but let's get into the crux of it. Trino is a distributed SQL query engine, which essentially allows you to perform fast SQL queries on large data sets. That's the gist of it. So Trino was created to empower analytics anywhere, and with proven scalability and high concurrency, users can combine data sources like, these are just some of my favorites, some of the ones that I come across a lot, but I can show you a couple, connectors that are available. BigQuery, Elasticsearch, MongoDB, Cassandra, separating, essentially the crux is separating compute from storage functionalities, right? So we covered that Trino is a high-performance MPP SQL query engine, essentially for interactive ANSI SQL queries, with proven scalability, high concurrency. Second main point, separation of compute and storage. Like, this is where, Trino is the fastest SQL query engine on a data lake. So, if you can essentially think about, you can separate the compute from storage and still get that scale and concurrency like a virtual data warehouse, then that's exactly what Trino did, right? So the ability to quickly and easily extract insights from large amounts of data, I'm talking like terabytes, petabytes, exabytes, is becoming very important to organizations these days. And as it becomes cheaper to collect and store data in the data lake, it is important that tools to query this data become faster, scalable, easier to use, and are more flexible. So using a popular query language like SQL can make data analytics accessible to more people within an organization, right? So I hear that, skill set has been one of the limitations for organizations, and SQL being one of the most prominent language, I think this becomes a win-win for everyone, right? So Trino is designed to be adaptive, flexible, and extensible. It supports a wide variety of use cases with diverse characteristics. So these can range from user-facing reporting applications with sub-second latency requirements to multi-hour ETL jobs that aggregate or join terabytes of data. right? And Trino actually is being used by organizations like AWS, Netflix, LinkedIn to deploy a single SQL system to deal with multiple common analytics use cases and easily query multiple storage systems while also scaling up to 1,000 nodes, right? Its architecture and design have found a niche within the crowded SQL on big data space. Adoption in the big data space is growing quickly, and thanks to the community, everybody is noticing this technology. But as great as Presto is, there was a need for an enterprise version of it, and that's where I think Starburst came in. There was a big opportunity to build upon open source Presto to create an enterprise grade Presto. And our founding team has been involved in Presto since the beginning. In fact, the creation of Starburst started at Teradata, where our three co-founders were already working on Presto, contributing significant time and engineering hours as the number two committers behind the number one committers of Presto creators. The Presto creators, in fact, are now part of our founding team. And since we are 100% committed to Presto, I would say 95% of those folks are actually part of Starburst. So Starburst was created on top of Trino to give you enterprise-grade performance, connectivity, security, management, and support your company's growing needs, right? So that scale, that concurrency, and that security that we talked about, that is essentially available in Starburst out of the box. So with Starburst, the enterprise-grade edition of Trino, you can now have a single point of access to all of your data, no matter where it lives, without needing to copy and move it. So we're substantially reducing the need to move the data and ETL pipelines. Starburst is also the analytics engine for data mesh, which is becoming a very popular, data strategy, a decentralized distributed approach to enterprise data management. And Starburst can be deployed anywhere and managed with insights. It's a very cool UI. You must take a look at it. But data teams can now holistically view their cluster operations, query executions, which group is querying what, so they can reach meaningful business decisions faster. And all this with the support of the largest team of Trino experts in the world, delivering fully tested, stable releases and available to support you 24/7. So to unlock the value in all of your data, you need a solution that easily fits with what you have today and can adopt the architecture that you want for tomorrow. So the ability to unlock more sources is definitely available, but Starburst gives you the fastest path from big data to better decisions. Okay. I wanted to give you a view into the connectors. I'll be happy to put that link in out of the box, what you get with open source Trino, as well as what do you get with out of the box in Starburst. So where do we actually fit in? We fit right between the tools your data users use. So on the right-hand side, if you see, there's Looker, Power BI, Click, Tableau. And on the left-hand side, pretty much all the tools that are available to data scientists. So Python, Spark, Jupyter Notebooks, they're the data scientists' favorite. We reside right in between the tools and the data sources they query. Okay, so data lake, data warehouse, the analytical databases, but as well as some of the operational databases. Some best practices must be applied, but that's just a quick introduction to Trino as well as Starburst. Any questions? I'm going to be available, in this session, so let me know. With that, I would love to pass it on to Barak to introduce you to the topic that we're going to be discussing today. Welcome, Barak.
Thanks, Neetu. Thanks for having me. I'm Burak Emre. I'm co-founder of Rakam and a data engineer, obsessed with open source stuff. I'm a huge advocate on SQL as well. And I have been in the Trino community for the last 5 years. Because before it was Trino, it was PrestoDB. And since the beginning, from 2015, I have been watching the news about the Trino, trying to be in the community. But the Rakam as a company was focused on the product analytics. So I can start explaining our journey, how we started and how we came up with this metric card and a new metric store on top of DBT. And Rakam is a product analytics company. Initially, we were building an on-premise product analytics tools, which lets our customers to collect all the company data into their data warehouse and uh, store it in a data warehouse. Actually, I have a slide that I can show it to you. Can anyone see my screen right now?
Yep, we can see it.
Perfect. So this was the initial product. So we have a bunch of SDKs from Android for Android, iOS browsers with JavaScript, and we had this Rakam API, which is still open source and being used by some of the enterprise companies to collect all this data into our customer service. So this tool was enriching the customer data, product data, and pushing it into a distributed commit log, something like Kafka or Kinesis. And we had this collector project, which listens the data, pulls the data from the distributed commit log, and push it into S3. So the initial product was mainly using PrestoDB. There's this connector called Raptor, which is not actually widely known. It is using ORC under the hood. We were storing all the data in ORC format in AWS S3 and utilize PrestoDB's distributed query engine for customer analytics queries. So these customer analytics queries involve some complex analytics requests like funnel, retention, cohort, which is not easily which cannot easily be written in SQL. So in order to be able to cover those use cases, we built some user-defined functions that process the data in memory-efficient formats. And we built a UI on top of this product analytics tool for product people, non-technical people to analyze the data in a way that they want. So they were just like they are using Google Analytics, they were clicking the funnel steps, trying to build some cohorts without writing a single line of SQL. Under the hood, our engine was making use of PrestoDB to be able to analyze the data. But we had some challenges because product data is huge. So you may have like tens of billions of data rows every week or every day, and to be able to ask simple questions such as what's my daily page view data over the last 2 weeks. This SQL query needs to process the data like needs to process tens of billions of rows, which is expensive and slow. So we had to come up with this data modeling language, or this. We tried a few alternatives, like building a streaming engine on top of PrestoDB. There are some tools similar to what we tried to do in the beginning, like Materialize or Kafka has SQL. Fling is a streaming engine. But we were not actually able to solve this data modeling issue. We couldn't be able to build an engine where you can process the data efficiently without the help of PrestoDB. But later, we realized that we need to be able to support the customers, the users that have their customer event data already in their data warehouse, because we were shifting to the world which we call a modern data stack. So this is a diagram of this modern data stack. So at the end of the day, we realized that this end-to-end tool approach doesn't really work. People use different tooling to collect the data, or they use ELT tools, they use some product analytics tools specifically, or they already adopted Tableau for BI. It's really hard to make them to switch to another BI tool, but we decided to split the Rakam API and Rakam BI and focus on the BI part. because people were collecting all their data into their data warehouse through data pipeline tools or ELT tools, and making use of this data with the preferred BI tool. Lately, we have this tool called DBT, which changed this which changed the paradigm. So they have this YAML like language on SQL where they let you define the data models, process the data within your data warehouse, and utilize BI tools, reverse ETL tools with this transform data. Because data warehouse solutions are really powerful, but great like power comes with great responsibility. When you are processing billions of data, there should be an intermediate layer like DBT, where you can just transform the data in a way that you want for the downstream tools, or test the data, document the data, have a data catalog where people can just look at the relevant data from a data catalog and understand where their data is. So the problem with this approach before MetriQL was that people need to connect to the DBT models from their BI tools. So most of these models are basically dimensional models where you have a single fact table like a page view table or events table where you have billions of rows, and you are just creating another dimensional table where we have this day and count of page views for that day, so that people can just use that table in their Tableau to be able to analyze the page views daily, because otherwise they will need to process billions of rows, which is expensive and slow. So we come up with this MetriQL tool that lets people to model data with DBT, define their metrics, and consume the data through the downstream tools. So that way, we are trying to understand the queries that are performed by these tools and write the query, an efficient query for the underlying data warehouse, so that we can just process the data in an intelligent way. So if you need some kind of transformation, if you are trying to speed up some of the queries, we put it into the YAML file. And actually, I have another diagram for explaining how MetriQL works. So DBT has these YAML files. This is a typical DBT project. And in this project, people basically write YAML files, build up YAML files, and document their sources, and create some SQL files and reference the other models, and build up a data lineage and expose to the data through these models. So what we did with MetriQL is that we just enhance DBT and let it to define the model in these YAML files, in addition to documenting their files and column definitions, and expose all of these data sets through an interface, which is TrinoDB. So the diagram is like the onboarding is as follows. You write these YAML files, and you connect to Trino from your BI tool or from your analytics tool. Instead of using the Trino URL, you enter the MetriQL URL. So since we are using Trino's query interface, we can talk to its protocol through Tableau. So that way, we don't require Tableau or any BI tool to be able to write a connector explicitly for MetriQL. So in that sense, we are just abusing Trino's SQL engine because Trino has this ecosystem, and there are many BI tools, there are many analytics tools that already integrates with Trino. So we are using this interface and understand the query to be able to make sense of the data. So essentially, when you connect to MetriQL from Tableau through Trino interface, it just sends these kind of queries. So if you look at this query, it is this all clerk and total orders. Total orders is our measure actually. So it's the count of all rows. But like without even this group by, people can just run this query, and our MetroQL engine gets this query and uses Trino parser to create an abstract syntax tree from this query and convert it to a DSL. So when Tableau runs this query, we understand that the person who are using Tableau actually use this orders DBT model, and total orders measure under the DBT model orders. And there is this dimension order clerk where we need to drill down the data. So we only support a subset of this SQL syntax, and we are not actually using Trino's query engine. So we just run a primitive version of Trino where we use some components like query interface and parser, and we just write the query for the underlying data warehouse. So if you are using Snowflake or Redshift or PostgreSQL, depending on the SQL dialect, we just write the query using the measure definitions, dimension definitions for the underlying data warehouse. So MetroQL is just a semantic layer on top of your data. It knows your data models, it knows your data tables, definitions, and when you are using some downstream tools, you just go through this dashboard. This is our simple dashboard. So we are trying to build up. This is not a marketplace. This is basically a catalog where you can expose this data through different tools. Like it might be Google Sheets, it might be Google Data Studio, or it might be Tableau in this case, or Python, just Python. So in Tableau, you just click the data set and it downloads a TDS file, and you double click it, and it asks you the credentials, your credentials. You enter your credentials, and it automatically starts like synchronizes all your metrics from your DBT project. So you don't need to define any metric in Tableau. You don't need to define the join relationships or anything. All the data modeling is essentially done in the DBT project. So the data analysts are actually analytics engineers model the data for once and expose this data through different downstream tools. That's the idea. And MetroQL is just the serving layer of your data. If you want to synchronize your metrics through different BI tools, every BI tool has their own metric definition. In Tableau, you cannot just enter SQL expression. You need to use Tableau expressions. In Power BI, you need to use DAX. In Metabase, you need to use Metabase expressions. So you need to learn their expression language. But everyone knows SQL, so we can just define all these metrics as SQL, and this engine just compiles the SQL for the underlying BI tool rather than you defining your metrics in each BI tool. And the cool thing is that I mentioned this simple use case where I want to see my daily page views over the last 2 weeks, and it requires me to process billions of rows. But in MetroQL, as part of these YAML files, you can just tell the system that I want to speed up the queries where for queries that have this total orders by order clerk. So here, the system actually automatically creates a DBT model, an incremental DBT model, which is responsible from incrementally computing the summary table, a roll-up table, in the target data warehouse. So we are not requiring you to send the data to a third-party service or to another storage. So all the data is in your data warehouse, but we use this dimensional modeling to create dimensional tables from your fact tables. And essentially what it does is that it just basically performs create table total orders by clerks as select clerk count star from orders initially. And when you run dbt, it inserts the new coming data, like incoming data from the last checkpoint time or max order date in each run. So you are updating this table in the background, and when we get a query just like this that can be answered with the rollup table, instead of querying the raw facts table, orders table, we just use the dbt model table. So here we are just write the query as follows. Rather than having this count all rows, we have sum total orders, because the table is an intermediate, has an intermediate state where I have days and count of page views, or count of orders in this case. And instead of processing billions of rows, I just need to process a couple of thousands of rows. So I can speed up all these queries, all the OLAP queries essentially with this metric query layer. And the cool part is that, like if you look at the metrics tools or historically what people were doing, they were exposing the API and expecting the tools to integrate with this Trino approach. We just use Trino's query interface to be able to integrate to 16 or 17 different data tools, because it's just SQL, and most of these tools talk to Trino already, and we are not just like using the engine, which is the which most overhead comes from the engine. So that's why it might be a bit hard to manage PrestoDB or Trino and use Starbus. But so here we are not processing the data, so it's just a simple API server. You don't need to have a distributed version of it. All the work is pushed into the target data warehouse. So dbt is having this heavy lifting by transforming the data, and we are just building this metrics layer. So there's this there's this thing called data mesh, where you treat the data as a product, right? So essentially, you can just have this product, a UI for your business stakeholders, and they can click the tool that they want to analyze, and they can audit their queries and embed these aggregates into your data model. Because looking at the usages of the data warehouse solutions, most of the work, I mean, most of the tools are like using this analytics workloads, having this dimensional tables. So everything, like not everything, but 80% of the queries are predictable. So if you can pre-process the data, create this summary table in advance, and audit the data, understand how long it takes to run typical queries, you can just efficiently build self-serve use cases for your end stakeholders. And if you have use cases where you need query federation, so that you need to fetch data from multiple sources, not just the signals data warehouse, you can use Trino, Trino's metric query integration, and use the connectors of Trino to connect to multiple data sources. Might be Snowflake or might be PostgreSQL. You can join the data in Trino and push the work into MetricQL. But MetricQL has different features for like writing query. Actually, historically, there was one specific feature that I created like 5 years ago in Presto. So this is aggregate pushdown feature. Trino has this capability to some extent. So when you run a query, if the connector supports pushdown feature, it can just perform predicate pushdown. So if you have a filter in Trino for a query for a table that is in your PostgreSQL, it can push this SQL query into into the PostgreSQL, and instead of getting the full table, it can get the data from that table in a filtered way. But in MetroQL, since we don't have an engine, we need to push all the work. So it includes things like predicate pushdown, aggregate pushdown, or join pushdown, or function pushdown. Presto doesn't have the aggregate pushdown feature yet, but Trino has aggregate pushdown. But still, Trino lacks this like function pushdown. So if you use substring answer SQL feature, it needs to pull the data from sources and does the heavy lifting of pushing the data. But with MetroQL, we just use a simple SQL syntax, and use Trino's query engine to be able to understand the query structure. But if you have a join relationship in between two different tables, you define the join relation here in your YAML file, and then we expose all the data in a single table to the downstream tools. So I have a simple example here. So here, like, you might have some cardinal or like unique features, like unique counting features. We understand the query structure. We support different aggregation types, and create the dbt model accordingly, and write the SQL query that is sent from the downstream tools accordingly. And if you have this join relationship, then we expose everything as single table, and create the join relationship in the ad hoc query. So here I have an example like left join. The end tool creates the SQL query using customer references, and MetroQuery understands that, okay, there is this relationship in between orders and customers, and I should write my query using left join relationship. So since we use a subset of this language, like the SQL dialect, we are able to understand the query in a much more better way. But we expose different querying interfaces. The first one is segmentation, where you can just set the data sets, define the major references, and we create the SQL query. And we have funnel, we have retention, we have raw SQL, where you can just reference Jinja. This is all ad hoc, and you can use our RESTful API or BI tools or SQL clients to be able to use this interface. And the Trino interface is called mQuery, our core feature for integrating MetroQuery to downstream BI tools. And we cannot convince Looker or Tableau to make the MetroQuery integration, so that's why we followed this approach. But I'm aware that this is a bit abusive as well, in a sense, and a bit tricky to understand. But feel free to ask any questions. I'm happy to answer.
Yeah, so we are waiting on any questions from the audience yet, but I actually have one myself. So I'm kind of curious if there is, how in detail or how in depth does MetroQL need to understand every single kind of data model, or particularly it really needs to basically understand the underlying data model or the schema. SQL language. This is what I'm trying to go for. Yeah. Of every single data warehouse that you're connecting to. Is that correct? I mean, you're pretty much that's all included in your library. That logic.
The cool part is that it's not two-way. So we understand the SQL dialect of all these data warehouse solutions, but we do not need to parse all their queries. The hard part is the query parsing part. So we use Trino's answer SQL standard. So when you are using a BI tool, and when it runs something like a function, substring function or concat function, we parse the query. We understand the dimensions and measure references. So if you have a virtual column defined in metric, you define it in the YAML file. And we expose these dimensions as regular database columns, table columns. And when this BI tool has the substring function or concat function, we get the query. We understand that, okay, the BI tool wants to query this dimension, or just it might be reference to a column or this measure, but it wants to have this projection of concat. So we map Trino's ANSYS SQL functions to the underlying target data warehouse function. So it might be the same function, substring function, or concat function, but we just compile it to the target SQL dialect, but we don't need to parse it. So the hard part is the parsing, and we use Trino's engine for it.
Right. So, but to me, actually, Trino solves the problem of the parsing, and then you have it in this AST format, right? So internally, there's a Java and I'm just to let everybody who hasn't played around with the parser yet, there's a Java library that is maintained by in Trino as part of the project, and a lot of people do use this as a tool to kind of basically convert any SQL, ANSI SQL, into an AST. Abstract syntax tree, and then you have these nodes that basically you can traverse at that point and make sense of what the SQL query actually means. So once you're in that form, I would say the hard part in my mind that I'm trying to wrap my head around still is you have to know all of the idiosyncrasies of every single, so Snowflake, and you have let's say Redshift, and all of these underlying data sources. And you have to actually maintain all of the changes possibly that they're making to their APIs, because they don't like, let's say Snowflake, for instance, and Redshift, they're totally proprietary. I don't believe there's anything that's just exposed. You as the vendor are essentially keeping up with all of those transformations and making sure that if we have something in this format, we have to make sure that it correctly gets translated for this particular function in this thing, for instance.
Yeah, you are correct. But the interesting fact is that most of the queries that we run in our data warehouse through BI tools are actually basic group by queries, like select dimensions, some count function, and order by limit and var. So we just have these mappings for each data warehouse for common ANSYS SQL functions. And for example, for common table statements with statements, most of them has similar dialects. But we implement an ANSYS SQL standard way of defining a data warehouse, and in addition to that, we customize the adapter accordingly for each data warehouse. So if a data warehouse does something nasty, doesn't comply with the ANSYS SQL standard, we just re-implement that part in our data warehouse integration. But it is not changing that much over time, because most of their customers are using the same interface for running the queries. And if they change the dialect, they need to update their data models. But
and on that, do you handle that versioning too? Because then if somebody has an older version of Snowflake that doesn't have that function, that's to me is like it could be a problem. So how do you handle that? Do you support specific versions, and how are you kind of curtailing that explosive set of use cases that you could possibly be solving for?
We don't have such a use case, but most of the data warehouses are backwards compatible. So they introduce a new function in their new version, and if the BI tools just use that function internally for Trino, which is mapped to that new function in Snowflake or Redshift, we just run the query on their Redshift cluster, and if it doesn't work, then we don't support that feature.
Got it.
So we push this work into the data warehouse, but we don't need to understand all their SQL dialect, only the subset of the use case that we have, because we don't need to parse their SQL. We just need to compile it to their SQL.
Yeah. And so you basically, and it's the similar thing that we do in Trino too. Like we don't support everything under ANSI SQL, right? Otherwise we would be supporting OLTP cases as well. So, but what you're basically trying to do to limit the scope of like everything that you could possibly be solving for, you're trying to limit that down to basically focusing in on a subset of use cases that are like the 99%. And then you, as people or maybe as your customers come to you and say, hey, we have this one particular use case that isn't supported by you, and then you'll bring that use case in as a one extra supported use case, depending on how much they pay you. Just kidding.
I mean, this is an open source tool, and we had some similar use cases in the past.
I see.
But the word that we believe in, that like we wanna like fully do it in an open source manner. The word that we believe in is that the data warehouse solutions are like powerful. The query federation engines like PressDB, Trino is really powerful. But when in terms to like analyzing this data in the downstream tools, most of the queries are predictable. So if you audit these queries, there can be an intermediate layer like MetriQL that understands the queries and creates intermediate tables or synchronize all your metrics with the downstream tools. So instead of connecting to the data warehouse directly, you can use MetriQL in between the data warehouse and these downstream tools, and don't need to define like data models logic into multiple places. It will be in your DBT project, defined in YAML, and you will be collaborating to data analysts. They are gonna create PRs, you are gonna review it, and you will merge it to the master, and you will have all the downstream tools synchronized to your master branch. So the software engineers are embedded this data space. So we have this continuous integration, continuous deployment in data as well, thanks to DBT. And MetriQL is just this connectivity layer, the serving layer. And we live in a world that the reverse ETL tools, the B2B tools will be on top of the customer data warehouse. So we will see some CRM tools, marketing tools living inside the customer data warehouse. Because we don't want to send our sensitive data to a third-party company. And these query federation engines like Trino or metrics layer like MetriQL help you to utilize the data in your data warehouse in an efficient way.
Oh, very good. Got a question from Chris. When should you use metrics defined through MetricQL versus aggregations? And I think this is two questions. Can I define these in a view and reuse them across multiple BI tools? So I'll give you the first question. When do you use metrics defined through MetricQL versus just raw aggregations?
So if you are experimenting, if you are a data analyst, or if you are a analytics engineer trying to understand the queries and data models, you use DBT. DBT's modeling feature where you just use Jinja functions and create the aggregations. And if you have a simple dimensional use case that you want to speed up some of the roll-up queries, like group by queries, you can use MetriQL. But for some of the things that are complex enough, something like sessionization or something like a multiple join referencing to multiple tables, and you need to apply some kind of complex projections in the SQL query. So for these use cases where you need a data lineage, you can use DBT's modeling feature and map your metrics as typical columns, typical measures in MetriQL. But if you just have a huge table and you want to speed up dimensional queries, then you can just create a DBT source without writing SQL, and create these YAML definitions. I want to speed up these dimensions and metric combinations. Then we can take the heavy lifting of creating DBT models. So complex logic, DBT. Simple dimensional logic, MetriQL. In the complex logic, you can use DBT for the modeling part and just use metrical for serving layer to that exposed model.
And then the kind of second part of that question is, can you define a view that actually you'll use across multiple BI tools?
Yeah, I mean, there are two different ways. The first one is that you can basically use DBT's models, DBT's views. So instead of creating a materialized view, incremental materialized view, you can use DBT's view feature, and it will be creating a view inside your target data warehouse, and we will be using that view in Metrical as the source of the model. But if you want to define metrics in a way that you want to treat the metrics as the first class citizen, DBT has new feature called metrics, basically. So it starts the support metrics as the first class citizen. You can use that feature to create a view on top of your models, DBT models, with metrical, and expose it to the downstream tool using the metrical as the serving layer. So different use cases for different modeling.
Awesome. Thanks for that question, Chris. And yeah, I think that was a good answer. Very cool. One last question I wanted to add in real fast is like, so I like the concept of, basically you could metric QL is this like layer that sits between your big data, or essentially your big data warehouse and or your cloud warehouse, and it essentially just like rewrites the queries for you, automatically speeds things up, and makes things a lot more efficient through the native query transformations. Wonderful. But then if you still want to have that query federation, you mentioned a little bit before. There's some sort of like way that I could essentially add MetricQL and then have Trino kind of sit on top of that and fit in that later? Does that work? Or would you need some sort of, is MetricQL required? Is there like a MetricQL connector that is required for that? Or is it like I still point to something else? How would you set that up?
Yeah. If you can share my screen.
Sure.
So here you see the supported adapters.
Yeah.
We use Presto. Like DBT has the first class support with Trino actually lately, so we should.
Yeah, we just added that in actually.
And have this tick green. So instead of connecting to PostgreSQL or Redshift, you can just use our Trino interface, Trino adapter basically, and connect PostgreSQL to Trino. So we will send the query to Trino, and Trino will pull the data from PostgreSQL and Redshift or anything else. Like it might be a RESTful API, even a RESTful API. So this query federation engine in Trino can just pull the data, perform the like query analysis, and return data back to the Metrica. So if you don't need query federation, if you only need a single data warehouse access, you can directly connect to the data warehouse. But if you need query federation, you can just use our Trino adapter feature.
Awesome. Well, Burak, thank you so much for stopping by today and sharing with us about the MetricQL. And I think it's an incredibly interesting way, to see the different ways that people apply Trino as not just directly using the query engine. You've used a very popular subset of the functionality in Trino, which is the Trino parser. And and I think the way that you've used it, especially adapting, you asked the question a long time ago to see if it could get added a while back, and you were like, well, this is kind of a use case all in of its own. And I really like the ingenuity that you displayed to kind of bring, kind of continue using the software and kind of continue integrating with us using the parser to make your life easier. But then at the same time, you made this whole new set of optimizations that and it's all done through SQL, which is another kind of interesting thing to show you that really the power of SQL and standardization and being able to just by simply rewriting a query actually makes such an impactful difference. and as well as roll ups and things like that. So thank you so much for joining, and we will. I'll let Neetu also do her sign off real fast.
Thank you, everyone, for joining us. Thank you, Barak. This was really insightful.
Yeah, very, very cool stuff. All right, and if Barak, if anybody needs to get a hold of you, how do they get a hold of you?
So thanks again for having me. As you mentioned, like we are just string builders. It's just simple string builder. So we are rewriting the query. So the task is not simple, but it's a simple solution to a complex problem using Trino's features. And thanks for asking questions, like Chris, Brian. I'm now sharing again my screen. I'm gonna show you this repository Metrica. This is relatively a new project. We have some early adopters, most of the data, the ELT vendors, and some customers, the users that use multiple BI tools with dbt. So I would love you to try MetriQL and give us feedback joining our Slack channel. And we are mostly online in Slack channel, just like most of our users and me. Happy to answer any questions individually in Slack.
Yeah, we should totally actually do a demo at this at some point. I'll reach out to you after this so we can actually have like a full length demo using Trino plus DBT plus MetriQL.
Yeah, so. Sounds great idea.
Okay. Oh, one last quick question. Does MetriQL act as like an ODBC driver?
So this is one thing that I would love to have in Trino. We use Trino's interface, and Trino only has GDBC. So we expose everything through GDBC to these well-known BI tools like Tableau, and for some of them we build our own connectors like Superset or Google Data Studio. But for ODBC, it is not open, and it's not a cool technology to work with, to be honest. But for Power BI integration, instead of using the ODBC connector, we will develop explicitly like an XML server, and we are not going to be using ODBC in any case.
Okay. Very good. All right. Well, thanks, Barak, again. And to everybody else, I wanted to quickly say thank you for joining us. Please give us a star on TrinoDB/Trino. Also give a star to MetriQL, and definitely show some love over there. Be really interested to take this on for a spin and play around with it. Also, do give us a follow at TrinoDB. Thanks, everybody, again for joining, and we'll see you next month.
Yeah. Thanks.
Thank you all.